So we have found relative error bound in previous lecture. So this is relative error less than or equals to norm of A multiply by norm of A inverse multiply by norm of R norm of B. And in right hand side, this norm A and norm A inverse that only depend on coefficient matrix. And from this relative error bound, we write the definition of condition number for matrices, and it is denoted by kappa of A is equals to norm of A inverse. Okay, so this number norm of A inverse, if this number is large, then relative error will be large, and if this number is small, maximum relative error will be small. So this is called condition number. And if you want to write relative error in term of condition number, then you can rewrite it, and you can write condition number in place of norm of A and norm of A inverse and multiply by norm of R, norm of B. And this condition number depend on context. In one dimension, we have also defined condition number that was x f dash by f. Okay, relative error in output with respect to relative error in input. But here condition number comes from norm. Idea is same that this number will control relative error. If this is bigger, relative error is bigger. But in one dimension, condition number was less than one, and we say that those those algorithms are well conditioned. And if that number is bigger than one, we said that those algorithms are ill conditioned. But here, one important remark is that condition number is always greater than one for matrices. So from this definition, as you can write A, and if you multiply A with A inverse, you got identity matrix. Okay. And if you take norm of identity, then this is one. Like you have 3 cross 3 identity matrix. Okay, so what will be the maximum now? This will be one. So norm of matrix is one, and you can write identity as A inverse. And if you use multiplication, triangular inequality in multiplication, then you can write norm of AB less than or equal to norm of A multiplied by norm of B, that is A inverse. And this is my condition number, norm of A multiplied by norm of A inverse. So this is, so you can see in inequalities, condition number is greater than 1. So for any square matrix, this number is always greater than 1, but it should not be much greater than 1. Like it can be 1, it can be 2, it can be 3, but it won't be like 1,000, 6,000, 4,000, something. Although it is always greater than 1, but not so much greater than 1. So likewise, one dimension we define here well condition matrices. And for those matrices, this condition number, I say this is close to 1. Okay, so it will be near 1. And on the other hand, for ill-conditioned matrices, if this condition number is much greater than 1. Okay, so condition number or conditioning in this context refers to relatively, so refer to relative error, and if this number is large, then relative error will be large, and if this number is small, and relative error would be small. So also, so when this number, when condition number is very large, so this is important point. So the solution of system Ax equals to B will be very sensitive, will be very sensitive for small changes in matrix A or in right hand side B. And on the other hand, when condition number is moderate or condition number is small, then there are small changes into solution corresponding to small changes in input. Okay, so what is condition number? So this is norm A multiplied by norm of A inverse, and it is, if it is small, we say well conditioned matrices, and in for well conditioned matrices they are not very sensitive for small changes. If you make small changes in, like you say in B, then there are small changes in solution. But if condition number is large, then matrix will be very sensitive for small changes. And now I go back to that example we have taken first. So you can take look at this example. Okay, so this system has solution, exact solution 1 1, but approximate solution is very much different. X1 is 1, so here X1 is 3. So there is a lot of change. And now we will compute condition number for this same example, and we will see that for this example condition number is very large. That's why you got wrong approximate solution. So let's relook that example. So question is that determine condition number for matrix A, which is 1 2, same example I'm writing 1.301 and 2. So in order to find condition number, you will need also A inverse. So first find A inverse. You can find it by finding adjoint, then divide with determinant of A. And this A inverse is minus 10,000, 10,000, 5,000, 0.5, and minus 5,000. Just find its inverse. Then find norm of A. Let us find maximum now. So what would be norm of A? फर्स्ट रो को ऐड कर दो, सम इज 3, सेकंड रो को ऐड कर दो 3.001, एंड बिगर वन इज so 3 point, this is the maximum norm of ठीक है, रो फर्स्ट रो को ऐड कर दो, सेकंड को ऐड करो, जो मैक्सिमम हो दैट इज द नॉर्म ऑफ मैट्रिक्स. सिमिलरली फाइंड नॉर्म ऑफ ए इनवर्स. नॉर्म ऑफ ए इनवर्स, सो कैसे फाइंड करोगे? मैक्सिमम ऑफ, add, take modulus and add first two entry, first row 20,000, then second row that is 10,000.5, and you can check that 20,000 is bigger. This is maximum now. So now condition number is norm of A multiply by norm of A inverse. So this is, you can say, norm of A 3.001 multiply by 20,000. So this is approximately 60,002. And this number, this is big, much greater than 1. So therefore, matrix A is ill-conditioned. And hence, it would be very sensitive for small changes. Also, I write an important remark here. Indirectly, you can say that condition number is inversely proportional to determinant of A. And, and for this example, you can say, uh, firstly, find adjoint, then divide the determinant. And you can compute determinant of A. So, determinant कितना आएगा इसका? Determinant of A in this example, that would be 2 minus 2.301. So that is 0 point minus 0.001. So determinant is very small, and in order to calculate A inverse, you are dividing with determinant. So that's why you got bigger A inverse. So entry of A inverse are much bigger than A. And then you take norm. So since entries are big, so norm is also big. And that's why condition number is very big. So in other words, condition number also depend on determinant of A, and it is inversely proportional to determinant of A. Okay. So if determinant of A is large, then so is condition number. Okay, any doubt in this definition?
Sir, if determinant of A is large,
Yeah.
then relation के according to K of A should be small, because आपने inversely proportional लिखा है.
क्या?
आपने inversely proportional लिखा है, तो if A is large, K has to be small.
नहीं, हाँ, तो इनवर्सली, सॉरी, मैं उल्टा. If A is small, okay, sorry. If determinant of A is small, then sorry, K is, लिखा तो ठीक है, then K is large. इनवर्सली प्रोपोर्शनल है, सॉरी. देखो ना, यहाँ पे डिटर्मिनेंट स्मॉल आया था ना, बहुत स्मॉल. दैट्स व्हाई कंडीशन नंबर वाज लार्ज. ओके, so it is inversely proportional. Let us take one more example, that how to find relative error bound. Let us take 2 cross 2 example. Let x star is an approximate solution, maybe computed by Gauss Seidel. That this is an approximate solution of system Ax equals to B, where A equals to 3.9, 1.6, 6.8, 2.9, और x क्या है? कॉलम वेक्टर x1, x2, and B is right hand side 5.5, 9.7. क्वेश्चन है फाइंड ए relative error bound. Okay, so find the relative error bound. So relative error bound is this x minus x star. So you can take any now, but I am taking infinity now. So this is less than or equals to norm of A multiplied by norm of A inverse, norm of residual divided by norm of B. So go step by step, calculate everything, calculate norm of A, then calculate A inverse, then find its norm, find residual, first find residual, then its norm, and also norm of B. Okay, so let us start. First, we find norm of A. नॉर्म ऑफ ए क्या होगा मैक्सिमम फर्स्ट रो को ऐड कर दो मॉडुलस लेके ऐड करना है सो दिस इज 5.5 3.9 plus 1.6 and then add second row this is 9.7 इनका maximum 9.7 now find a first find a inverse and its determinant is 0.43 और जॉइंट कैसे लिखते हैं जैसे 3.9 है तो 3.9 रो और कॉलम छोड़ दो ये एंट्री 2.9 then minus 1.6 first write matrix of cofactor then take its transpose फिर 1.6 के कॉरस्पॉन्डिंग लिखोगे 1.6 के कॉरस्पॉन्डिंग 6.8 आएगा ठीक है बट देन यू इंटरचेंज रो एंड कॉलम तो ये यहाँ वाली एंट्री यहाँ पे आ जाएगी okay and 0.43 is the value of the determinant you can calculate and you can write here determinant of A is 0.43 so A inverse is adjoint divided by determinant and you can take 0.43 inside so divide each entry with 0.43 so this is my final answer write at least 4 decimal places when you are doing rounding or chopping so try to write 3-4 digit after decimal now take its norm सेम वे में फर्स्ट रो को ऐड कर दो 6 प्लस 3 लगभग 9-10 बनेगा और सेकंड को ऐड करोगे 15 प्लस 9 24 तो सेकंड वाला बिगर है 24 पॉइंट प्रिसाइसली 24.8837 ओके देन यू आल्सो नीड टू फाइंड नॉर्म ऑफ बी राइट हैंड साइड थी 5.5 एंड 9.7 जो सबसे बड़ा हो दोनों में that is 9.7 and now lastly find residual so what is residual this is b minus a x star is approximate solution so b is given 5.5 9.7 minus a coefficient matrix x star approximate solution computed solution that is also given 0.98 1.1 okay तो पहले मल्टीप्लाई कर लो देन सब्ट्रैक्ट so final answer is minus 0.0820 minus 0.1540 then find norm of r दोनों में जो relatively bigger component है try to locate that component and you can check second one is bigger ठीक है मॉडुलस में जो बिगर हो फर्स्ट तो 0.08 है सेकंड 0.015 है so this is so finally put everything in that bound राइट हैंड साइड पे कैलकुलेट कर लो. सो नॉर्म ऑफ ए multiply by norm of A inverse 24.8837, norm of R divided by norm of B. So simplify it, this is 3.8321, and if you calculate in percentage this is 383 approximately. Okay, so much bigger, and you can see, but we don't know exact solution, but relative error is bigger, so computed solution is not so computer solution is wrong, you can say. Okay, and sometime you also has some symbolic entries. For example, find the condition number for matrix A. So entries are 1 constant c 1, and it is given that constant c is not equals to plus minus 1. Find the condition number. Also, for the when does matrix A become ill conditioned? And next part is how condition number is related with determinant of A. Okay, and maybe you may ask in exam that make some interpretation, make some comment, okay, about this matrix. So firstly, try to compute condition number, that is norm of A. Let us take maximum now, multiply by norm of A inverse. So firstly I am finding determinant of A, वो क्या होगा 1 minus c square, and also you can write adjoint if you want to write separately. Adjoint will be 1 minus c 1. Therefore A inverse is adjoint divided by determinant. सारी एंट्री को 1 minus c square से डिवाइड कर दो. Okay, so this is A inverse. So now write norm of A. Norm of A क्या होगा? अब यहाँ पे सी नेगेटिव हो सकता है. फर्स्ट रो को ऐड करोगे 1 प्लस मॉड सी, सेकंड को भी ऐड करोगे 1 प्लस सी. तो सी नहीं लिखना आपने, मॉड सी लिखना है. ओके, इफ सी इज नेगेटिव यू टेक मॉडुलस. दोनों रो का सम सेम ही है, सो दैट वुड बी सेम. देन राइट नॉर्म ऑफ ए इनवर्स. इसमें भी फर्स्ट को ऐड करो चाहे सेकंड को ऐड करो, बोथ आर सेम. सो दिस सम इज 1 minus c square plus c, दोनों रो सेम ही है ना, ऐड करोगे मॉडुलस लेके. और यू कैन राइट देम टुगेदर 1 plus mod c divided by 1 minus c square modulus. So you can write condition number. So multiply norm A with norm of A inverse, that is condition number. Okay, so condition number is finally norm of A, this one, multiply by norm of A inverse. and you can collect two terms in numerator, so that will be 1 plus mod c square. And it is given in question that c neither plus 1 or minus 1. That makes sense. If c equal to plus 1, denominator will be 0, so condition number is infinity. Okay, and you can say if you go back, so inverse is not possible when c equal to plus minus 1. Okay, denominator would be 0. तो c मॉड ऑफ c 1 होने का मीनिंग है कि c प्लस 1 और माइनस 1 नहीं है, बट इट कैन बी नियर 1 और माइनस 1. When this number c, let us say c is 0.999, then 1 minus 0.99, difference of two small number, same number, sorry, that difference will be small. So 1 by small, that will be one very large number. Okay, so in other words, if mod c is close to 1, close to 1, then condition number A of matrix A will be much greater than 1. That is, A become ill conditioned. So that answer second part. If you go near 1 or minus 1, condition number will be very large and matrix is ill conditioned. And second part is how it is related with determinant. So as I said that 1 minus c square, ये कहाँ से आ रहा है? 1 minus c square कहाँ से आ रहा है? डिटर्मिनेंट से आ रहा है 1 minus c square. So if determinant is small, condition number will be large. Okay, so as I explained earlier, condition number is inversely proportional to determinant of A. And when condition number is large, the solution of the system Ax equals to B is very sensitive to small changes in matrix A. तो न्यूमेरिकल एनालिसिस में वो एल्गोरिथम, वो स्टेप्स टेबल होते हैं जिसमें स्मॉल चेंज इफेक्ट ना करे. ठीक है, अगर स्मॉल चेंज इफेक्ट करेगा तो उनको हम बोलते हैं इल कंडीशन. ठीक है, so matrix is ill conditioned when condition number is large, and in that case determinant will be small and system will be very sensitive if you make any changes in coefficient matrix A or in right hand side B. Okay, so that's it about uh, condition number and relative error.